What's up, guys? I'm going to show you how to taper these walls and do 3D servicing on these pockets. Alright guys, now that we're back, I'm going to throw in my step file, and Mastercam can import just by clicking and dragging a file. So now I've got my solid imported already. You can also open using this, or even clicking on merge, and you can select your SolidWorks file or a step file or STL or anything like that. For instance, if I want to just open this file, I would click open, and I have to click this all files, or if I knew the extension to my file, I can click on step, and that will give me the available files. Otherwise, they won't show up if it's showing up as a Mastercam file. The next thing I want to do is click on options, and I want to enable my edge curves, and that will import the geometry from the solid. So then I'll click that and then don't save, and it'll open up and bring in all of the lines otherwise. Now, if I didn't have that option and I just clicked and dragged my file over, now if I imported my file and it didn't have any lines, what I can do is go to my wireframe and click on curve all edges. Now I can triple click to select the solid body, and then I can move this window out of the way and click end selection. Now this is going to put all my outlines on everything. That'll be helpful for doing our boundaries for later. So since I've started with a new file or part, my geometry, it needs to be oriented. So if I click on my top view, that is actually my front view. So what I want to do is rotate this so that the pockets are facing the top where the spindle would be. So a quick and easy way to do this would be to create a new plane off of a face. So if I open up my planes manager down here, if it's not open, then we can go to view and select planes manager right here. I'm going to click this create a new plane, and we're going to select solid face. And I'm just going to select that, and I want to orient it so that my X is to the right and my Z is pointing upwards. So then I can click OK, and I can name this pocket surface. So then I'll click OK, and now my grid is sitting right where I need it. So that's probably the quickest way. In other situations, you might want to actually orient your block by rotating it so that you have top, front, and all those views that correlate to the actual surface. So I want to go to my machine and I want to set default. So for this video, I'm not going to show you how to do feeds and speeds. I'll leave that up to you. But I'm going to show you how to get the tool paths. So let's go to stock setup, and I'm going to click on all entities. So this will enable my stock boundary. And you can see now I have my stock shading sitting within this block. So I'm going to turn that off, and I'm just going to click on the top view, and I can press Alt-1 or right click and press this top button. Let's go to tool settings and assign our tool numbers sequentially and warn of tool duplicates. So click OK, and now the first thing I want to do is rough out these pockets. So a really handy tool to use is OptiRough. Now we come up with this window, and this is going to be our machining geometry and our avoidance geometry. For this purpose, what we're going to do is we're going to click on this button and triple click to select the solid body. And now I have everything selected, and I'll click end selection. Now I have 62 entities available. I'm going to leave 50 thou stock on the walls and 50 thou stock on the floors. We're not going to touch anything on here. If we go to toolpath control, if we include our silhouette boundary, that's going to include the outside block boundary, and it's going to contain the tool within the material. If I didn't have that, it would try and machine the walls, and let's say that our stock is already to size. So I want to make sure that I have that silhouette boundary, and I want my strategy to be on the inside to do the pockets. I'm going to select a tool, and I'm going to create a tool, and let's go with a bullnose end mill. And we're going to say that this is a 3/8 bullnose with a 30 thou rad. And we're going to ignore our feed rates for this. So we'll call this rough pockets. My next step is going to be to cut parameters, and we'll set our step distance to 10% so we can use a lot of the flute and we don't wear out the corners of our cutter. I'm going to use my step down, and we're going to set this at 0.75 inches, and we're going to include a step up. So this will go down 3/4 of an inch and start machining as much as it can, and then as it goes up the tapered walls, it's going to go up 37.5 thou. My micro lift distance I usually set to 0, and I'll set my back feed rate to 200 or 500. I like to have my percentage of tool diameter to keep down within 500 or 300%. That way it doesn't do unnecessary moves. For small spaces, it'll just move over using our back feed rate. My linking parameters can generally stay within the defaults. The only thing I really want to check at this point is my planes and make sure that they all say pocket surfacing. Let's turn on our coolant and generate the toolpath. Okay, while this is generating, I'm going to collapse that, and I'm going to do a raster. And I'm going to set this to these surfaces here. Now, if I zoom in and roll it around, I should have only those surfaces, and I'm going to set my avoidance region tangent to those surfaces. So anything that touches those machining surfaces. So then if I hide my dialog here, I should have red touching all of the green. If I press escape, that should bring the window back up. I'm going to set these to 0. Now I'm going to go to my tool, and I'm going to create a new tool, and this will be a ball nose end mill, and this will be a 1/4 inch. And I'll click finish, and we're going to parallel this small section. So I'll go to my cut parameters, and I like using zigzag. I'll set my step over. This is usually pretty good surface finish with a 2/10 scallop height, which our step over ends up being 14 thou. And we're going to leave our machining angle at 0. We're going to go to our linking parameters and just verify that these are all within the defaults. If you've changed anything, you might have a good reason for doing that. If we go to planes, we should have surfacing, and we'll turn our coolant on and click OK. So this is what my parallel tool path looks like. But let's check our rough pocket since it was generating. Now we have some material being faced across the top. So I don't really want that. That's unnecessary for what we're doing. So I'm going to go back into my parameters, and I'm going to go to my steep and shallow and set my minimum depth to -1 thou. Now this is going to generate, and it's going to do everything within the pockets now. Alright, so now that we've got everything generated for my roughing application and my parallel, I want to contour my pockets in here. So I'm just going to go to my contour, and I'm going to select the entire solid, so I'll triple click and end selection. So I have my drive surfaces. Now I'm going to set some containment boundaries. Now I can select using the geometry on the part. Sometimes there might be really obscure lines that you might need to chain, so I would have to zoom in really far to get to this one. You can also click on the red arrow or even the blue arrow, and I just want to have this meet up with this green arrow. So then I have a blue and a green arrow, and that is my boundary. So I'll click OK, and I'm going to use the 1/4 inch ball nose end mill, and we'll leave these as default. Now my maximum step down, I know that my scallop is going to be 14 thou. Now if you didn't have a tapered wall, it would be okay to do a larger step down. I'm going to go to climb and one way, and I will also use my follow surface. So this is going to run around the edges and then follow the surface. So I'm going to select optimize cut order, and then I'll click OK. Now this will generate for this smaller section. Now it might be wise to set up your toolpaths in sections so that you don't generate too much and then you have a crash. Mastercam has some issues with generating toolpaths and crashing, so if you limit the possibility of it, it makes it a lot better. So let's call this contour round. And I want to copy this and paste it. And I want to select a new containment boundary, and that's just going to be this one here. So I'm just clicking on the red arrow to go around, and I'll have to zoom in to this section here, and we'll go around our paralleled section. So click OK, and then we'll have this generate. So my next path, I'm going to use a waterline on this one. So we click expand gallery, and we'll use waterline, and we're going to select the whole solid by triple clicking. We're going to set this to 0 and 0. And then we'll set our boundary chains, and if I change this to C-plane, then I can pick that chain. Otherwise, if I were to click 3D, it's going to stop at each branch. So to make it easy on you, you just click C-plane, make sure the chain is selected, and click on that. Now I want to make sure I have tool contact points selected. That means if it goes outside of the boundary, the only reason it goes outside of the boundary is because of the tangent point of the radius. We're going to continue using our 1/4 inch ball nose, and we're going to waterline a large pocket. We'll go to cut parameters, and we're going to go from bottom to top, and we're going to go one way and climb. Actually, let's go climb spiral. It gives a little more gentle movements. My step down is going to be 14 thou, so we figured out our scallops. And we don't need to add cuts because we don't have any other tangent walls that might change angles. You can also have waterline step over on floors like this. I wanted to go to my planes, make sure that those are good, check my coolant, make sure that's on, and click OK. Now this is going to go from bottom to the top upwards. Now my next toolpath, I want to cut these flats. So I want to go to horizontal. Once again, I'm going to triple click on the solid and set these to 0. Now my toolpath control, I'm going to set my boundary chains, and we're going to use the C-plane boundary, and I'll use that one and that one. Click OK. And we go to our tool, and I'm going to create a new tool. We're going to use a bull nose end mill. We're going to give it a 1/4 inch in diameter and 15 thou radius on the corners. Now I'll click finish, and we're going to flatten the bottoms. Now if we go to cut parameters, I'm going to change this to 1 cut, And we're going to do an XY step over of 45%. And I'm going to change this to 500%. Now my steep and shallow, I want to make sure that this is negative 1 thou once again, so we don't do the top, but those boundaries should help contain it. And I'm going to make sure my plane is correct and coolant is on. So now this is going to do these top surfaces and the bottom surfaces in everything, and it has a helix that will enter in. Now if we were to verify these operations, now this is going to be my roughing, so it'll open up my pockets, and then it'll start doing some step ups. Now I'm going to turn on my color loop by pressing verify and click color loop. And my next operation is going to be that parallel toolpath. And then I'm going to do my contour to do that inside boundary. And then my contour for this one. Now we're going to use Waterline, bottom to top. And then what we'll do is we'll go in with our 1/4 inch end mill and flatten the bottoms. Now you can see in here there's a little bit of a scallop left over because of the 1/4 inch radius on the ball nose versus the other end mill that we're using. And down here we have a little bit of material left over from the ball nose. So we're going to have to go in and clean that up. So how I'll do that is I'll use a Waterline. Once again, I'll just copy this and paste it. And I'm going to use my steep and shallow with a minimum depth of negative 0.9. So it won't go any higher than negative 0.9, but it'll go all the way to the bottom inside of that pocket. I'm going to make sure that I have the correct tool set, so we'll use that 1/4 inch bull nose. And we're going to change the step downs to 3 thou. We're going to continue going bottom to top, and we're going to climb spiral. And that should be it. So now it's going to do a small little section to clean up what was left over. Now, in the bottom here, I might want to do a scallop for the faces. So what I'll do is I'll just triple click on my solid and set my stock to 0 on both, and then go to my boundary chains, and I want to select this boundary, and I want to select this boundary. Now I have to go into 3D, so I might have to cancel that one and go around this bottom part, because I don't want it going any higher than my radius. I want to set my tool contact point, and we're going to make sure we have a spherical, and we'll go into our cut parameters and set this to 14 thou for step over, or you can set your scallop height to 2/10. Now you can also control the distance or the height that it will go on those radii, because 0 degrees is going to be a flat bottom. Now if we take a look at it, with 0 to 90, it's going to put in the entire bottom. Now I might want to go into my steep and shallow and change this to 1 degree. And now it only limits itself to this one. However, this one needs a little bit more. So maybe we could drop it to 1/2 degree. Nope. So now that I've got my toolpath like this, I'm going to name it. And we're going to do finish bottom surface. Now if I select all of these and go to my verify, it'll rough out my pockets. And then I'm going to parallel, and then I'll contour my pocket, and the next one, and then I'll waterline, and then I'll clean up the flats, and then this one will go down and clean up this small section down here. And now my last toolpath, we're going to clean up those bottoms, and you see how it kind of blends everything in. So that's 3D pocketing in a nutshell. Thanks for watching.